Hello, everyone. My name is Sebastian Galicia, and I'm a third-year undergraduate student and a member of the Burton Research Group in the Department of Civil and Environmental Engineering at UCLA. Today, on behalf of my co-authors, I will give a brief synopsis of our latest study, a sociodemographic analysis of Unbraced, Unbolted Cripple wall retrofits in the city of Los Angeles. To start, disparities in seismic risk mitigation programs can lead to uneven impacts during an earthquake and increased burden on socially vulnerable and underserved communities. The study examines the extent to which the distribution of cripple wall retrofits in residential buildings located within the city of Los Angeles vary based on the sociodemographics of the affected population. The effect of the earthquake brace and bolt program on the disparities in the retrofit rate distribution is also assessed. We collected seismic retrofit data for cripple wall buildings in LA City from the Los Angeles Department of Building and Safety and the Los Angeles County Open Data Portal. The key relevant data fields obtained from these sources include the permit date along with the retrofit cost. We also collected data for the 1 and 2 family residences located within LA City, with location, year of construction, and home value being the data fields of interest for the study. Lastly, we assembled socioeconomic data from the U.S. Census Bureau and ESRI at the neighborhood and census tract levels. Specifically, variables related to higher education, race, income, and home ownership were of primary interest to the study. In total, we have developed a data set of 5,435 cripple wall retrofits in LA City that have occurred since 1999. As mentioned in the previous slide, a complete inventory of the approximately 2 million single and two-family residences in LA City was also compiled, with a large portion of these buildings constructed prior to 1980. Relative to this complete inventory, the histogram for the retrofitted buildings is less skewed, which is indicative of the prevalence of cripple wall construction prior to the 1970s. Lastly, the median and average retrofit cost is $3,500 and $6,500 respectively. With this data at our disposal, we investigated the association of different sociodemographic variables and the retrofit rate. To assess the spatial distribution of cripple wall retrofits, we mapped the 114 neighborhoods and 7 regions of LA City. From this figure, we observe that the majority of retrofits are in the central, northeast, and south LA region. For a more concise representation of the distribution, retrofit rates at the census tract scale were established by normalizing the number of retrofitted buildings by the total pre-1980 building count. Even after performing the normalization procedure, the observation regarding the concentration of retrofits in central, northeast, and south LA still holds true, with moderately high retrofit rates sporadically distributed across the other 4 regions. These high-level observations led us to clusters of neighborhoods with unusually high retrofit rates. One cluster of 7 neighborhoods in central LA accounts for 18% of retrofits, despite having 3.4% of all pre-1980 single and two-family residences. The other cluster of neighborhoods, also situated in central LA, accounts for approximately 14% of retrofits, despite having 2.5% of all pre-1980 single and two-family residences. Notably, both clusters have been identified as having significant levels of gentrification over the last 2 decades, hinting at the underlying reasons for the existence of such disparities. To reduce the seismic risk to single-family dwellings with cripple wall construction, in 2013, the California Earthquake Authority established the Earthquake Brace and Bolt program. The program gives eligible homeowners grants to cover the cost of retrofitting dwellings with the cripple wall vulnerability. As part of our study, we evaluated the distribution of retrofits relative to the EBB eligibility criteria, which is established at the zip code level. The first key observation is that most of LA City is eligible for the program, with a small cluster of zip codes to the western part of the San Fernando Valley and the Verdugos region not meeting the eligibility requirements. To further investigate the other eligibility issue, we mapped the bivariate distribution of the age of the 1 and 2 unit residential buildings and site seismicity. By comparing both maps, we can begin to observe that the EBB program is successful in targeting regions with higher high site seismicity or older residential buildings. Furthermore, we considered the distribution of the site seismicity and a mean building age for the complete inventory partitioned based on the EBB program eligibility. Through statistical analysis, we confirmed our observations that the EBB zip code eligibility is consistent with the priority of retrofitting elder buildings in regions with the highest seismicity. The next portion of the paper focuses on the association between the retrofit rates and various sociodemographic factors. We first considered the sociodemographic characteristics of the 10 neighborhoods with the highest retrofit rate. For a given sociodemographic variable, the value for the given neighborhood is normalized by the value for all of LA City. Thus, a value greater than 1 indicates that a specific group or category is overrepresented, whereas a value less than 1 indicates underrepresentation. In these neighborhoods where the retrofit rates are the highest, the percent white and Asian populations are higher than the average value for LA City. The median home value and percentage of individuals with higher education are also considerably higher in these neighborhoods. In contrast, the percent Black and Hispanic populations are lower than the average values for LA City. Notably, however, these disparities appear to have been reduced with the introduction of the EBB program in 2013, as shown by the comparison of the pre-2013 and 2013 onward retrofit inventories. Conversely, in studying the 42 neighborhoods with the lowest retrofit rates, we also observe underrepresentation and overrepresentation of particular demographics. Notably, the percentage of Hispanic households is higher in these neighborhoods, whereas lower values are observed for the percentage of white households, the percentage of households possessing higher education, and median home values. Nonetheless, we once more detect a general trend in the reduction of disparities through the introduction of the EBB, with majority of the ratios converging towards a value of 1. To further probe the issue of retrofit rate disparities and the effect of the EBB program, we examined the neighborhoods with the highest representation of groups that were shown to be underrepresented in places where the retrofit rate is highest. Upon normalizing retrofit rates by the average retrofit rate for all of LA City, we observed that the 10 neighborhoods with the highest percentage of Black households have low retrofit rates, most of which increased after 2013. To deal with the issue of confounding, the standardized mean building age is also taken into account for each of these neighborhoods. Nevertheless, we found that the neighborhoods with the greatest prevalence of Black households have generally low retrofit rates despite occupying older buildings. Similar results were obtained when examining the normalized retrofit rates and standardized mean building age for the neighborhoods with the highest percentage of Hispanic households. Moreover, the normalized retrofit rates are significantly lower for these predominantly Hispanic neighborhoods, even after the introduction of the EBB. More detailed discussion of these results are provided in the paper, along with an investigation into the correlations between the retrofit rate and the sociodemographic variables at the census tract level. That was a quick summary of the overall approach and significant findings of the study. Please check out the paper linked there on the slide for more details of our work. Thank you for listening. We greatly appreciate your feedback on the paper, which you can share under the YouTube comment.